Design strength of fillet weld. Since the load transfer is through shear, the fillet welds are designed for shear strength. So shear strength of fillet weld is given as area of the weld, that is length of the weld, into throat thickness into stress, that is FUW by root 3 into gamma MW, where throat thickness is given as K into S, where K is a factor and S is size of fillet weld. Let us say this angle is theta. K depends on the angle theta, that is fusion angle. From the figure, throat thickness is given as, say this is size of the weld S and this is also size of the weld S. Then throat thickness is S into, this angle will be theta by 2. So S into cos theta by 2. From this is equal to Ks. So K is equal to cos of theta by 2. So K depends on fusion angle between the faces. IS 800 gave specifications for the value of K for different angles between fusion faces. Between 60 to 90 degrees, K value is 0.7. Between 91 to 100 degrees, it is 0.65. Between 101 to 106, it is 0.6. And between 107 to 113, it is 0.55. 114 to 120, it is 0.5. So for theta less than 60 degrees and more than 120 degrees, fillet welds are not suitable. Are not preferred. Whereas S, the size of the weld, is given as, if say this is S2 and this is S1, and if S2 is greater than S1, then size of weld is smaller one, that is S1. So size of normal fillet is minimum weld leg size. This is a weld leg in which minimum is S1, so it is minimum weld leg size. Whereas in this case, little penetration is beyond the plate. Say it should be minimum of 2.4 mm penetration. Then size of weld is minimum leg size, minimum leg length plus the 2.4 mm penetration beyond the root run. So this is penetration beyond the root run. Minimum size of fillet weld is specified by IS 800 2007 in table 21 based on thickness of thicker part connected, that is up to 10 mm thickness, it is 3 mm size. So minimum size of fillet weld is 3 mm in any case, so it should not be less than 3 mm. And for connected plates between 10 to 20 mm thick, size is 5 mm. Between 20 to 32 mm, it is 6 mm. Between 30 to 50 mm, it is 8 for first run and 10 for minimum size of weld. Let us say here the thickness of the plate is say 10 mm and this is 12 mm. Then the size of weld minimum should be, S minimum should be, since the thicker plate is 12 mm, 12 mm is between 10 and 20, so minimum should be 5 mm. But in this, when the minimum size of fillet weld given in the table is greater than thickness of thicker part, the minimum size of weld should be equal to thickness of thinner part. The thicker part shall be adequately preheated to prevent cracking the weld. That is, if this is of 5 mm thick and this plate is of 22 mm thick, the thicker plate is 22 mm, which is between 20 and 32 mm. S minimum from table should be 6 mm, but code specifies minimum should be, since the thinner plate is less than the size of the weld, so S minimum should be 5 mm only. Whereas maximum size of fillet weld, for in the case of square edge it is S maximum is thickness of thicker plate minus 1.5 mm, whereas for square or round edge S maximum is T minus 1/4 of T, that is 3/4 of T, where T is thinner plate, thinner connected plate, thickness of thinner connected plate, and also the preferred welds are given. This is a desired weld, then this is the accepted because of throat thickness is full. This is not accepted because the reduced throat thickness is present. The maximum size is permitted in order to avoid wash away of weld, and whereas for long joint there is a reduction for the size of weld, reduction for design strength of weld when long joint, that is LJ, is greater than 150 times the throat thickness. Then the long joint factor is beta LW, which is given as 1.2 minus 0.2 times of length of the joint by 150 times of throat thickness, which should be less than or equal to 0.1, where LJ is length of joint along the load direction and T is effective throat thickness. So this factor should be multiplied to the design shear strength of fillet weld in case of long joint.